Hello everyone, this is Komali Varma. Let's get started with the paper discussion of PTRP. Before getting into the paper discussion, let us have a look upon the syllabus and important concepts to be covered. The first, I hope you guys are able to see the screen. Yeah. So let's get started with the syllabus. Unit 1, we have probability theory. Unit 2, we have random variables and operations on one random variable. And Unit 3, we have multiple random variables. Coming to Unit 4, we have operations on multiple random variables. And Unit 5, we are having random process. So let's get into some of the important concepts. In Unit 1, the important concepts are definitions of probability and its axioms. Next one is probability as relative frequency, total probability based theorems and its problems, probability, conditional probability problems and properties, independent events and problems. Coming to Unit 2, we have distribution, expectation, moments, function that give a moment, and transformation of random variable. And coming to Unit 3 and 4, we have joint density function and its properties and problems, joint distribution and its properties and problems, distribution and density of a random variable, statistical independence and problems, and inequalities. Coming to Unit 5 and 6, we have random process, classification, stationary concepts, time averages, ergodicity, Gaussian random process, autocorrelation function and its properties, Wiener theorems, and autocorrelation problems. And coming to next one, we need to show that a random process is a Whiteson stationary process and problems based upon it. And next one is power density spectrum and its problems. So this is the syllabus and the important topics to be covered. Let's have a look at the question paper. Yeah. So firstly, we have the 2 marks. What are joint and conditional probabilities? Define covariance function, state central limit theorem, list any 2 properties of jointly Gaussian random variable, give an example for discrete random variables, define second order stationary process, define Wiener relations. Next one is state and prove probability theorem, total probability theorem. Next one is a question based upon the probability is given. Next one is about the distribution and density function. Next one is about time averages and ergodicity. Explain Whiteson stationary random process. And fifth question is the properties of cross correlation function and problem on autocorrelation function is given. Next one is if p of x is equals to x by 15, where x is equals to 1 2 3 4 5 and 0 otherwise. Here is another problem based on the functions. Next one, a problem is statistics is given to 3 students, so on. And here is another problem. Show that the narrow band noise process can be expressed in phase and quadrature component of it. Random variable has a probability density function, and you need to find out e of x square, and e of 6x plus 4. So in the 8th question, you have given the theory part where you need to describe about the Schwarz inequality, convolution and mean of system response, and power density spectrum. So let's get to the solutions of this paper. So starting with the 2-mark questions. So the first question is, what are joint and conditional probabilities? The probability of P of A intersection B is called joint probability for 2 events A and B. Mathematically, it can be represented as A intersection B is equals to P of A plus P of B minus P of A union B. So what you need to write here is about, you need to write the definition of the joint probability and its mathematical equation. Next is conditional probability of an event A, given by P of A by B is equals to P of A intersection B by P of B, where P of B is not equals to 0 and also P of B is greater than 0. And you need to write about the conditional probability, its mathematical equations, and where we have P of A by B. Conditional probability P of A by B simply say the fact that the probability of event A may depend upon the second event B. For mutually exclusive events, P of A by B is equals to 0. That implies P of A intersection B is equals to phi. So for the 2 marks, if you write the definition and the mathematical formula for both the joint and conditional probabilities, that is enough. Now coming to the definition of covariance function. So the covariance function is generally given as Cx of y is equals to E of x comma x bar into y comma y bar is equals to variance is equals to sigma xy. Autocovariance function Cxx is equals to E of x minus x bar whole square, and C of xx is equals to integral minus infinity to infinity x minus x bar whole square fx of x dx. For independent events, C of x comma y is equals to 0. If C of x comma y is equals to 0, covariance function is 0. C of x comma y is equals to E of x comma x bar into y minus y bar. That implies it is equals to 0. Next, coming to the central limit theorem. Central limit theorem says that the probability distribution function of the sum of a large number of random variables approaches a Gaussian distribution. Hence, this is the statement of the central limit theorem. Hence, therefore, he asked us to write the statement. So, writing the statements is enough. Any true properties of jointly Gaussian random variables. You need to write the properties of jointly Gaussian random variables, where some of the properties are like Gaussian random variables are completely defined through only first and second order moments, that is by means, variance and covariance. If random variables are uncorrelated, they are also statistically independent, and you can write other properties which are easy for you. Next one is give an example of discrete random variable. So if asked like this, just define what is a discrete random variable. Discrete random variable corresponds to the random variable x having only discrete values while t is continuous. And the example you can give it of your own choice. And the example mentioned over here is number of children in a family, number of students that come to class on a given day, the number of eggs that a hen lays in a given day. Next one is define second order stationary process. So you need to define the stationary process and write its corresponding equations. The process is called a stationary to order 2 if its second order identity density function satisfies fx of x1 comma x t1 comma t2 is equals to fx of x1 comma x2 t1 plus delta plus t2 plus delta. Now the correlation E of x1 into x2 is equals to E of x of t1 into x of t2 of a random process. In general, it will be the function of t1 and t2. Let us define autocorrelation function of a random process x of t as rxs of t1 comma t2, where rxx of t1 comma t2 is equals to E of x of t1 into x of t2. Now define Wiener relation. Xx of omega is equals to integral minus infinity to infinity rxs of tau e power minus j omega t into d tau, and rxs of tau t is equals to 1 by 2 pi integral minus infinity to infinity sxx of omega e power j omega t into d omega. That implies sxx of omega is a Fourier transform pair with rxx of tau. Now what is total probability? State and prove it. Statement. The total probability P of A of any event A is defined on a sample space S can be expressed in terms of conditional probabilities. Suppose we are given n mutually exclusive events Bn is equals to Bn, where n is equals to 1, 2 to so on up to n, whose union is equals to S. These events satisfy Bm intersection Bn is equals to phi, where m is not equals to n, and it is equals to 1, 2 so on up to n. So the given is that what we need to prove is that P of A is equals to summation of n is equals to 1 to n P of A by Bn into P of Bn, which is known as the total probability of an event, and you'll be solving it in this way, where the statement given is, and you'll consider the Venn diagram, and you'll write the information below, and you'll solve it in this way. So it is from distribution laws, and you'll use mutual exclusive events, axioms, threes, and using those you need to solve this total probability theorem. Next one is the question where a single card is drawn from 52 card of deck, and he has the probability that the card is a jack. So the number of favorable outcomes is 4, and the total number of outcomes is 52. So we divide 4 by 52, where we get 1 by 13, where it is the probability that the card is a jack. What is the probability that the card will be a 5 or smaller? So the total number of outcomes that when we pick up a card is 5 or less than 5 is 24, and the total number of outcomes is 52. The probability of the card that will be 5 or smaller is, when we subtract 1 minus 24 by 52, we get the answer, that is 7 by 13. The probability that the card is red, 10. Number of favorable outcomes is 2, as we have only 2 cards. The total number of outcomes is 52, so we divide 2 by 52, that is 1 by 26. Third question, define the distribution and a density function and their properties and prove any one of the property. So let us write what is a distribution function and what is a density function and its properties, and let's prove one of it. So the distribution function, the probability p of x is less than or equals to small x, is the probability of an event x less than or equals to x. It is the number that depends upon x, that it is a function of x. We call this function as cumulative probability distribution function. It is denoted as fx of x. Thus it is given by fx of x is equals to p of capital X less than or equals to small x. The argument x, small x, is any real event or number ranging from minus infinity to infinity. The distribution function, these are the important properties of a distribution function, which you need to remember all of them. They are fx of minus infinity is equals to 0, fx of x is fx of infinity is equals to 1, 0 less than or equals to fx of x is less than or equals to 1, fx of x1 is less than or equals to fx of x2 if x1 is greater than if x1 is less than x2, p of x1 is less than x less than or equals to x2, then fx of x2 minus fx of x1. Now coming to the last one, fx of x plus is equals to fx of x. Now coming to the definition of density function, the probability density function, it is denoted by fx of x. It is defined as the derivative of the distribution function. Small fx of x is equals to derivative of capital fx of x by dx. We often call fx of x just the density function of the random variable x. Fx of x is equals to sigma I is equals to 1 to n p of xi into del of x minus xi for discrete random variables. Now coming to the properties of density function, probability density function, we have fx of x is greater than or equals to 0, where the probability density function is a non-negative one. Integral minus infinity to infinity fx of x dx is equals to 1, where the area under the probability density function is 1, that is unity. Next is fx of x is equals to minus infinity to x fx of v dv. Now coming to the fourth property, we have f of x1 less than or equals to x2, that is equals to x integral x1 to x2 fx of x dx. Now coming to the next question, we have a random variable x is known to have a distribution function fx of x is equals to u of x into 1 minus e power minus x square by b, where b is greater than 0 is a constant. Find its density function. So given is a distribution function, and we need to find out the density function. So if a distribution function is given and we need to find out the density function, what we do is it's the differentiation. So we know the formula of density function. Fx of x is equals to derivative of, that is d by dx of probability function, that is fx of x. Now you need to substitute the value of fx of x in the equation. and by substituting the value with the given condition, you get fx of x is equals to 2x by b into e power minus x square by b into del of x. Therefore, the required density function is fx of x is equals to 2x by b into e power minus x square by b into del of x. Next one is explain briefly about time averages and ergodicity. So what we need to do is that we need to write it in brief about the time averages and ergodicity, its equations, its definitions, and its theorems and everything. In short, the time average of a quantity is defined as x bar is equals to a of x of t is equals to limit t tends to infinity 1 by 2t integral minus t to t x of t dt. This is the formula for the average quantity. The time autocorrelation function, it is denoted by rxx of tau is equals to a into xt plus x of t plus tau. That implies limit t tends to infinity 1 by t integral minus t to t xt x of t plus tau dt. Now coming to the ergodic theorem, if x bar is equals to capital X bar and rxx of tau is equals to rxx of t, the process that satisfies the ergodic theorem, the process that satisfies the above equations are called ergodic theorem, and it is known as ergodic process. Ergodicity is very restrictive from a stationary, and it may be difficult to prove that it constitutes a reasonable assumption in any physical situation. If a random process satisfies x bar is equals to capital X bar, then it is called the mean ergodic process. If random process satisfies rxx of tau is equals to rxx of t, then it is called a correlation ergodic process. Two random processes are called jointly ergodic if they are individually ergodic and also have a time cross correlation function that equals the statistically cross correlation function. Now coming to fourth question, explain Whiteson stationary random process. So, from the second order stationary random process, we know that autocorrelation function is given as rxx of t1, t2 is equals to e of x of t1 into x of t2. So now let's consider tau is equals to t2 minus t1. Then the equation becomes rxx of t1, t1 plus tau is equals to e of x of t1 plus tau is equals to rxx of tau. The process is said to be Whiteson stationary if it follows the following conditions. As we know, the conditions for Whiteson stationary process. These two are the conditions. E of x of h is equals to x bar. That implies it is a constant. Next one, e of x of t into x of t plus tau is equals to rxx of tau. A process stationary to order 2 is clearly Whiteson stationary, but converse is not necessarily true. So this is one of the conditions of Whiteson stationary process. So if you write this much and expand it, it is more than enough. Next one is state and prove the properties of cross correlation function. Here you need to learn the properties of cross correlation function, where rx of y of minus tau is equals to rx of tau. It follows even symmetry, and rx of modulus of r of xy into tau is equals to less than or equals to root over rxx of 0 into ryy of 0. Third one is modulus of rxy of tau is less than or equals to 1 by 2 rxx of 0 plus ryy of 0. Now it is the proof for the it is the proof that it is having an even symmetry, where rxy of minus tau is equals to rxy of tau, where you consider rxy of tau is equals to e of x of t into y of t, and which it can also be written as rxy of tau is equals to ex of t into y of t plus tau, where t plus tau is equals to a. Rxy of t is equals to f of x of a minus tau into y of a. So from the above these equations, rxy of tau is equals to rxy of minus tau. The next question given is find the mean and autocorrelation function of a random variable x of t is equals to a, where a is continuous random variable with a uniform distribution over 0, 1. So let us write what is given in the question here, where a random process x of t is equals to a is given. It is continuous random variable with uniform distribution over 0, 1, where fx of x is equals to 1 by 1 minus 0, that is equals to 0 for the given condition. It is between 0 and 1, and it is 0 for remaining since it is a uniform density function. Now the mean is given by e of x of t is equals to integral minus infinity to infinity x of t fx of x dx. This is a formula where you need to substitute the given conditions in it, where if we substitute it, we get the answer of e of x comma t is equals to a. Now the autocorrelation function, it is given as rxx of t1 comma t2 is equals to integral minus infinity to infinity x of t whole square fx of x dx, where we have integral 0 to 1 according to the given conditions and limits. A square into 1 is equals to dx, where you get a square. So the required mean and autocorrelation function of x of t and are a and a square, where we are given a uniform distribution function, and we find out the mean and autocorrelation function using the respective formulas. Next one is a random variable has a probability density function f of x is equals to 5 by 4 into 1 minus x power 4 for 0 less than x less than 1. That is, it is between 0 and 1. We are asked to find out e of x, where e of x is equals to integral minus infinity to infinity x of fx dx, and where e of x square formula is integral minus infinity to infinity x square fx of x dx, where we substitute the values of fx of x in the formula e of x and e of x square. By substituting, we get the formula e of x is equals to 5 by 12 and e of x square is equal to 5 by 21 in the formulas shown here, where the formula for e of x is equals to integral minus infinity to infinity x fx of dx, and for e of x square is equals to integral minus infinity to infinity x square fx of x dx. Now we need to find out e of 6x plus 4. That implies e of 6x plus 4 into e of 1, where you can take out the constant out, as we know that e of 1 is equals to 1. So we have this answer e of 6x plus 4 is equals to 13 by 2. So this is the last question, sixth question, where you have given p of x is equals to x by 15, where x is from 1 to 5 and it is 0 otherwise. You need to find out p of x is equals to 1 or 2, and that implies p of that is equals to p of x is equals to 1 plus p of x is equals to 2, where we have 1 by 15 plus 2 by 15, that implies 1 by 5. So p of x is equals to 1 or 2, we have that is equals to 1 by 5. Next one is b. P of b, the given conditions are p of a is equals to 1 by 2, that implies p of a bar is equals to 1 by 2, p of b is equals to 1 by 3, that implies p of b bar is equals to 2 by 3, p of c is equals to 1 by 4, that implies p of c bar is equals to 3 by 4. The probability that the problem will be solved is that p of a union b union c is equals to, we know the formula, p of a plus p of b plus p of c minus p of a intersection b minus p of b intersection c minus p of c intersection a minus p of a intersection b intersection c. Since they are independent events, p of a union b union c is equals to p of a plus p of b plus p of c minus p of a into p of b minus p of b into p of c minus p of a into p of c plus p of a into p of b into p of c, where the given where we know the values of p of a, p of b and p of c, so we need to substitute over here. So by substituting, we have the values 12 plus 8 plus 6 minus 4 minus 2 minus 3 plus 1 by divided by 24, which gives us 18 by 24, which again reduced, which gives us 3 by 4. Hence these are the some of the, this is one of the previous paper which we have discussed. So what we have observed is that he has mainly focused upon the important topics which we have discussed, that is from the unit 1 it is total probability 1 question, and from unit 2 the problems were given from joint density function and distribution function. A function is given in distribution function where you need to convert it into the density function, and next one is about the White-Sense stationary process, power density spectrum, and classification. So what we have observed is that most of the concepts were from unit most of the questions were from unit 3 and 4 and 5 and 6, which you need to concentrate more upon them, which are very easy topics too. So if you just know the formula, you can just keep on doing the sums and its applications. So from the first chapter we have got the problems upon the total probability, that is to derive it. So these are the questions.